Good morning, class 9th. Today I am going to explain the numerical problem based on law of constant composition. So, sample problem second state that calculate the mass of carbon present in 2 gram carbon dioxide. Now, as we know, carbon dioxide, that is CO2, contains carbon and oxygen in fixed ratio by their mass. So the ratio of carbon and oxygen here is mass of carbon is 12, number of oxygen atoms in CO2 is 2 multiply atomic mass of oxygen, it comes out to be 12 ratio 32. By more simplifying it, the value comes out to be 3:8. It means in carbon dioxide molecule 3 gram of carbon combines with 8 gram of oxygen to form 11 gram of carbon dioxide, that is C plus O2 gives CO2. So it indicates that 3 gram of carbon combines with 8 gram of oxygen to produce 8 plus 3 11 gram of carbon dioxide, or we can say that 11 gram of CO2 contain carbon. How many grams are present? 3. Clear? Now 1 gram of CO2 contains carbon equal to 3 divided by 11. Now multiply by 1. We have to calculate the mass of carbon present in 2 gram of CO2. Therefore 2 gram of CO2 contains carbon equal to 3 multiply 2 divided by 11. It comes out to be 6 divided by 11 is equal to 0.545 gram. It means in the carbon dioxide having 2 gram amount, the amount of carbon present is 0.545 gram. Okay, now next problem for practice question number 1. Problem for practice question number 1. The statement is calcium carbonate CaCO3 contains 40% calcium, 12% carbon and 48% oxygen by mass. This percentage is now given in the form of mass. It means in calcium carbonate or 100 gram of calcium carbonate, that is 100 gram of CaCO3 contains 40 gram of calcium, 12 gram of carbon and 48 gram of oxygen. Clear? Given is that calcium carbonate contains 40% of calcium, 12% carbon and 48% oxygen by mass. Knowing the law of constant composition holds good, calculate the mass of the constituent, that is carbon, calcium, carbon and oxygen present in complete 2 gram of calcium carbonate. So let us start. Now it is clear that the percentage of carbon, calcium and oxygen in 100 gram of calcium carbonate was found to be 40 gram of calcium, 12 gram of carbon and 48 gram of oxygen. Now the total molar mass of compound, total mass of calcium carbonate, atomic mass of calcium is 40 plus atomic mass of carbon is 12 plus 3 multiply atomic mass of carbon is 16. It comes out to be 100 gram. Therefore the molar mass of calcium carbonate comes out to be 100. Now we have to calculate the mass of the constituent elements, that is calcium, carbon and oxygen in 2 gram of calcium carbonate. Therefore now the mass of calcium in 2 gram calcium carbonate is equal to 2 multiply 40, because we have given 40 gram of calcium, divided by total mass of the element by using the formula, that is percentage of element in the compound or mass of element in the compound is equal to mass of the element divided by mass of the compound. Given mass of compound is 2 gram, therefore multiply 2 and 40, it comes out to be 80 divided by 100, that is 0.8 gram. It means 2 gram of calcium carbonate consists of 0.8 gram of calcium. First case. Second case, mass of carbon in 2 gram calcium carbonate comes out to be 2 multiply the given mass of carbon is 12 divided by 100. 100 is the mass of this compound calcium carbonate, it comes out to be 24 divided by 100. It means it comes out to be 0.24 gram. Third case, mass of oxygen present in 2 gram of calcium carbonate. To multiply mass of oxygen 3 atoms comes out to be 48 divided by 100. It comes out to be 96 divided by 100, that is 0.96 gram. These are the amount of calcium or the mass of calcium, carbon and oxygen in 2 gram of calcium carbonate. The second problem for practice is apply the law of constant proportion to calculate. Apply the law of constant proportion or constant composition to calculate mass of oxygen that will be used for combustion of 5 gram of hydrogen gas. We have to calculate the mass of oxygen that will be used for combustion of 5 gram of hydrogen. Now given to us is mass of hydrogen gas, given is 5 gram. The equation for the reaction is hydrogen undergo combustion to produce H2O. When we balance the equation, it comes out to be half H2O. This indicates that 2 gram of hydrogen, because atomic mass of 1 atom of hydrogen is 1, atomic mass of 2 atoms of hydrogen is 2. It will give 16 gram of oxygen. Now 1 gram of hydrogen produces 16 by 2 gram of oxygen. We have to calculate the mass of oxygen present or used for combustion of 5 gram of H2. Therefore 5 gram of hydrogen comes out to be 16 multiply 5 divided by 2 gram of oxygen. Therefore the value comes out to be 40 gram. Hence 40 gram of oxygen is used for combustion of 5 gram of hydrogen to produce water. In this way we can calculate the mass of oxygen that is used for combustion of 5 gram of hydrogen.